Yeah, so this is the syllabus. So the first 20% is part of the fundamental network. And we have these much topics. So today we have planned to complete the topic till 1.5 TCP to UDP. So we will cover 1.1, 2, 3, 4, and 5. And related to this TCP UDP, I have added one more topic so that this TCP and UDP, whatever this thing is, we can see the application of these two protocols. So this is kind of a protocol we have. So this we will see also the application, why we have this kind of things in the in the network technology. So I'll quickly start. So the first topic says is a router. So if this is the one, so see if so before knowing the routers and switches and the other equipments, first we need to know what is network. So network is actually group of devices which is interconnected. Okay, so just like think about your home where you have IP camera, you have a personal computer, you have a particular switch, you have a alarming system at your home, you have more than 2 or 3 PCs which you want to have the interconnection between. So it's just like a small network which you have, and now you want to have the connection between those devices. So if you are able to make a connection, that would become a network, that would become a small network for you. So so making that network, why it's important, so that you can communicate. So in currently, just like if you want to your camera, the IP camera is recording something, okay, and then you want to see that recording on your mobile phone or on your PC. So in that case you need a network, because your IP camera is somewhere else and you are sitting somewhere else, or you maybe your PC or the monitor is somewhere else. So your IP camera and your monitor where you want to watch the video or do the surveillance, then for that you need a network. So that is actually a requirement of network. So this is very small example, because what happened, because in the current situation or the global, if you go for the global scenario, we have very big networks. Each and every devices are interconnected, and based on that we are communicating. So that is a complete network. So network basically we just divide in a three particular types. So first is the local area network. So local area network is very small network. So it can be a small office. Think about 1 or 2 floor of office you have. There you have 10 or 20 systems and a particular servers to and your laptops, your PC, your other devices. So it's a small network. Generally, we consider it like within 100 meters or 100 meters of the cabling, which is sufficient to make that network. So that is very local area network. It's less like it's a very small area where you have a small number of devices, just like it may have 2, 3 switches, one router, 10, 20 PCs. So there is no limit or any particular number to give for the local area network, but that is a small network. Just like think about a campus in a college. So in a campus of the college, there is a Wi-Fi network. There is their own laptop and their own computers, which is there for for providing the services and to maintaining the database of the employees of their employers, of their teachers and other thing, whatever syllabus they are going to. So for that, they just develop a small network. So that is local area, very small area, and they are maintaining it within a small area. So that is called local area network. Similarly, we have one more network, which is not written here, which is MAN, which is Metropolitan Area Network. That area is similar to local area network, but it is stretched to a particular city. So think about a bank which have two branches in one city, and they want to connect those two branches within a city so that they can have the communication. They can have the wire transfer. They can have the updates to each other. They can have the chat with each other. So for that, if they are having, so it's a small area within a 10 kilometer, you may say 5 to 10 kilometer of the network, then it may be it is considered to be a metropolitan area network, very small network, where you do not want to where there is no cabling more than 10 kilometers, where you don't have big networks, more number of devices. Than those are also part of the network. There is also category which we used to say metropolitan area network. Then there is third network, which is a bigger one. Very bigger one is wide area network, which is completely worldwide connection, where just like you are sitting somewhere and I am sitting in somewhere of the world and we are communicating. So we are communicating via wide area network. So the area of this network is very big. It is intercontinental. It can be connected to more than one countries. So kind of condition if we have, that is wide area network, which is very big scale of the network, more devices, more computers, everything is there. So that is a condition where we used to say wide area network. So it's a geographical area is very big for the wide area. So the basic categorization is happening here based on the area, the geographical area we have. So based on that, we categorized. So think about a company which is having a branch in a particular city. So in a branch, what they have a number of computers. They may have printers, they may have IP camera, they may have a particular servers which may be locally situated to have to provide some small services. So that would become a local area network. That would be a small network for that branch office. Now that company have one more office, which is maybe in somewhere else in a country, right? So, so if now the condition and that company wants you or someone to connect those two branches, right? So in that case, two local area networks because separated with a branch. So because the branch is a local area network, that is very small area they are maintaining, and now they are interconnected. So those two LAN is now connected with a WAN technology, right? So now the two networks are there. One is local area network, which is locally given to a particular branch now, and then another branch is also there. So that is also a local area network. Now the both local area network is connected with a WAN, wide area network. So now those two country branches are interconnected. So that's how we differentiate based on the geographical area. So that is a local area network. Now you know the wide area network. Equipment and devices are mostly are same, but in local area network we have small number of devices, and that may be not having that much capacity. But in case of wide area network, we have very bigger capacity. We need some bigger capacity of router and other devices so that we can at least provide the services. Okay, so this is two kind of network. So basically that is that we need to learn about the network, and this is the two types. Now, if we say so in case if we want to create a local area network or wide area network, then we need some devices. So devices are first, if you say is, so what is the devices? So let's start with this one, router. So what is router? Router is a layer 3 device. Okay. So layer 3 device means it can handle the layer 3. Layer 3 is coming from the OSI layer. Okay. So if you go and check on the OSI layer, you will see the third layer say L3, layer 3, network layer. Network layer means layer 3. Layer 3 is basically means IP addressing. Okay. So every single device in a network is having a IP address. That is actually a IP address is identity of that particular device in a particular time frame, where it can be given statically. A device can have a static IP, which is you can configure. Okay, that is just like a static one. Or it can also have a IP from the dynamic source, where a dynamic server, which we have a server or maybe a router, which will become a DSCP server, dynamic host control protocol is there, which will provide a particular IP address. So there will be a pool to given to DSCP server, and from that pool, it will give a IP to you. Just like in case if you are sitting in your home and you are using your phone, right? So when you connect to the Wi-Fi, do you configure IP address? Like, do you do like
Yeah.
go and configure IP address for your Wi-Fi, or is it a automatic? Just like you just switch on your laptop and just connect to your Wi-Fi. Do you go and configure IP address, or is it a automatic process?
It's an automatic process.
Right. So that automatic process is coming from a particular protocol, which is called DSCP. I will tell you about that. So DSCP, what DSCP protocol runs? So whenever you just switch on your Wi-Fi, your laptop wants to get an IP address, because without IP, your laptop cannot communicate to the internet or the internet. So for that reason, what your laptop will do, it will, if the Wi-Fi adapter will start a stack, a particular software will be run behind your screen, and it will try to get a IP address. So that is a layer 3 protocol, and that IP address is always needed to be provided to a single devices in the network. That is the identity of that device. So just like, so that is called IP. Now once you get a IP address, so consider there is a scenario you want to talk to the another computer or the another side of the network. Then that device also have a IP address, right? So that two IP address needed to have the communication. But how you will communicate? There is some method or some device or technology to be there to have the communication, right? So let's say you are saying hi to your friend. So one computer is saying hello to another computer. So that computer will become a source, and it will create a packet, a data packet, and will encapsulate in a different type of packets, and will try to send it. So once it will try to send it, it will need to know the destination. Just like you are sending a postcard or a letter to someone. So what you will do, you will write the address of the receiver, right? You will just give this particular address, I need to send that particular mail. Then you will give it to the post office. Then the post office will take it and will try to give it to the where you wherever you want to send that particular. So for that, it needed to be have technology. So those two IP addresses, one will be the source and another will be destination. Those needed to be have the routing is just like need to. So there will be more devices, there's not will be single. So I will tell you 1 minute. Let me connect my one. Let's have a dash whiteboard. So 1 minute. Okay, so let's say there is a there's an internet. Okay, this is a kind of internet. We have multiple devices here, and there is one device which is at your home. That is your home router. Okay, this maybe you are purchased with some ISP provider. So internet service provider will sell you one router, and you are sitting here a lab with a laptop. Okay, so now this laptop, then one more guy will have similar router or maybe different company router, and he will also have one laptop here or computer here or whatever he can, maybe a mobile phone or some technology where we can just receive the message. So now there will be one device which will be at the edge of your internet, and similarly here as well, edge of internet that is actually connected like this. And this is also connected like this. Now, then you have one PC. So just maybe you are with a Wi-Fi you can connect, or maybe it's a single LAN connect, cable connection you can also do with your, with your router or the LAN cable or the modem. So there is a bigger routers are there in an internet network so that they can manage the traffic. So now this will have one source IP address, and this will have one destination when just they are talking with each other. So this guy wants to talk to this. So for that, it will need a L3 layer communication. That is so this L3 layer communication can only be done by two kind of devices. So one is the router and another is the L3 switches. So the router is the device which usually have communication with layer 3 and need to manage with the IP address. So this router, how this router will manage the IP address and other things. So what it will do, it will always create a routing table. And in the routing table, it will try to know the destination or the hopes to provide. So whenever this guy, So this guy will maintain a routing table. Routing table will say, okay, for this destination, this particular destination, you need to send the packet to this particular interface. Like that, it will always maintain a routing table. Similarly, think about one more connection is there, which is like here, and it is also connected to a edge device. So this router will have two connections, and this device also have the connection to particular one more guy, which is here. Now the destination will be different. This guy will also have a different IP address. So based on that, what happened? Now this another routing in that same routing table, this may have one more entry. Okay, for reaching this guy, you need to select this path and then you can send the packet. So this communication will happen based on the source and destination IP address. Source and destination. So the router will maintain a routing table written like, okay, this is the source, this is the destination, and this is the path or the interface from where or the next hop. So next hop IP address is also given here, or the interface can be given here. So based on that, this can be have the communication. So this is basically a router. Mostly Cisco have these many routers, bigger one and a smaller one based on the other application they have. Similarly, we have layer 2 devices. So layer 2 devices are basically a LAN devices. Those are switches. Switches are mostly deal with the layer 2. Layer 2 means in a OSI layer, OSI model, the layer level, the layer 2. Layer 2 means data link layer. Data link layer means what happened? Like there basically they will deal with the MAC addresses, not the IP addresses. Okay. So MAC addresses and other thing will whenever deal with the MAC addresses, they will have the layer 2. So layer 2 will be basically in a local area network. Just like think about this. This computer is connected to one switch. This computer is this switch, this. Then they have a core switch or the switch which have the all three switches connection. So this computer wants just PC1 wants to talk to PC3. Then they do not need to go to the WAN or the router. They can talk with each other in a single LAN. Here also they can have the communication based on the MAC addresses. They do not need to go to outside, but they surely need an IP address, but they do not need to go to WAN or the wide area network or any other particular destination. So they can talk. So basically this can be this communication is called L2 communication, layer 2 communication. This can be happen based on the MAC addresses. Okay. So this is layer 2, and layer 2 devices are switches. Earlier, there are two more devices are there. So one is called hub and another is bridge. But those are not having those are not in use now because those devices are too old to manage. So what happened? So those two devices, one second. So hub is a device which is just like a repeater. Okay. So think about there's one laptop which is connected to this particular hub, and there's one more laptop which is connected to this hub, and this is like this connected. This is also connected, and this is one more laptop which is connected to this. And if this is a hub, okay, HUB. So, and this is a connection. That's how it's connected. So now when this is A, this is B, and this is C. Okay. So if they want to talk, happen. Okay. So this guy wants to talk to B and C. Okay. So if hub is there, when it will send a packet, this hub don't have that much intelligence to identify the destination. Okay, so what it will do, the same signal, the electrical signal which hub it will repeat it to this and this. Okay, and similarly, if you think there is more connection to with this hub, it will just repeat that signals to everyone and it will increase. And this is not a good sign because it will because in this condition, every interface, every connection will be utilized. So this want to talk to this guy, but everyone receiving. This is also not so a secure way of communication, because if this guy wants to talk to B, the communication should be only between them. It shouldn't be like everyone will receive the same packet. And in that condition, what happened? Everyone knows what this guy wants to say, this guy. So that is a hub. That is very old technology. This is not in use right now. Similarly, so what happened, and this is one more problem. So what happened, this kind of situation is called collision domain. Okay, so see what happened, like A wants to talk to B, and this is C, and then he sent a hi message. Okay, so this guy received hi message, this guy also received the hi message. Okay, now they wants to reply. Okay, so this also receive hi, and this also receive hi. They just want to reply hello. Okay, so he also send a hello message, this also send a hello message. And now in a hub, what happened, when both the signals come, it will be distorted because there is two same signal, two same condition hello messages for this hub. So if there is one signal came from here, same signal come from here, this guy will repeat it, then the same signal goes to this, and the signal, one signal and another signal plus plus happen, and then the signal will be distorted. So in that condition, this condition is called collision, because what happened, like this particular two messages came simultaneously in a one timing, same timing they replied, and at the same time this message come to this wire, and that message will be distorted. And this is called collision because two messages collide and collision happen. So the hub will always create a single collision domain. Everything here which is connected to hub having a single domain. One domain, this is a single domain, and that will call collision domain. Why collision? Because collision can be happen. If this guy will transmit a packet at the same time, this hub is not able to send it or not able to regenerate it, and the message will be distorted, and the A will not receive the A will never receive that message. So that's why this is called collision domain. So this is a technology collision. So in earlier, this is a known problem. So what that time this guys what done, this guys created one protocol which is called collision CSMA CD. So this they develop. So this is called carrier sense multiple access. So multiple guys can access a carrier. So this is a carrier because this is a wire is here a carrier, and hub is also. So multiple device can access a same carrier. So what happened, before sending a message, we will send a sensing message to know whether this carrier is busy or not. If carrier is busy, we will wait. There is some timer. There will be some timer. Maybe think about 5 minutes. Okay. So when it will found, okay, carrier is busy, it will wait. It will try, it will just do for some wait for 5 minutes. Okay. And then again try to sense the carrier. Again, this will found if the carrier is busy, then it will wait for another 5 minutes. Okay, and once it will found, okay, the carrier is free, then only it will send the message. So based on that, this will be waiting time. And in current scenario, nobody wants to wait for 5-6 minutes. If you want to say hi to this guy, will you wait for 5 minutes? So this is not a good technology. Okay, we have carrier sense multiple access in an older day. This is 1970s or some 60s or 70s till this was in use. Nowadays, we don't have this because we have better technology to deal with. So this kind of a protocol, CSMAST, carrier sense multiple access CD, that was in use to prevent the collision. Okay, so that is a hub. Similarly, if we have one more device, so one more device is just like think about this is a hub. This is a hub. So there is one more device which is a bridge. They used to say it bridge. Okay. So if a bridge is there, so hub is connected to bridge. So a hub, this bridge have some technology so that it can devise the collision domain. So this is a bridge. So think about this is a bridge. Okay. And this is a hub. And this is also a hub. This is connected to one PC. This is connected to one PC. So now this what this will do, it will create a different, so this will become your one collision domain. Okay, and this will become your another collision domain. So bridge can, what bridge can do, it's kind of a switch. Okay, it will just create on this interface a domain, a two-bit bridge domain. So this is called two separate collision domain. Okay, so this a bridge can do. In that way, in that case, bridge can manage, just like if A wants to talk to B, this is B. So in that condition, what happened? This hub will send this packet to the bridge, and bridge have that technology so that it can send, it will not use CD like a CSMA, and will try to send. And this, in that condition, B again, when the another device is connected, like think about there's one more device which is connected to this same hub, and this also wants to send the packet at the same time to this carrier. So bridge will try to manage, it will have some buffering kind of technology, so that it can buffer the message, it can wait, it can just save that message on in his memory and then wait, and the device do not wants to wait. But that will also a problem, because this will also create latency in the network, because this is also buffering is there, then the buffer is full, then what happened, like you need to wait. So this is also not a good technology these days. So now we replace it with a switch. So those switches called layer 2 devices. Similarly, there is a one more device which is layer 3. Layer 3, what happened? They which have routers and routers property as well as switches property. So when a device can do switching and routing both, that would become a your layer 3 switches. That actually, the layer 3 devices is nothing but a router with the switching properties. So those, some of the interface of the layer 3 devices, or we used to say layer 3 switch, can be configured as a switch, and some of the interface can be configured as a router. So that is called layer 3 switches. Okay. So just like think about in your requirement, you do not need to, you do not want to spend your money for the router, because router are expensive. Then you can purchase, and you have very limited requirement, then you can purchase a layer 3 switch. Okay, and then you can have your routers, you can have your router properties, and you can also have your LAN property. Just like these days, we always have layer 3 switches at our home. So consider just like your Wi-Fi modem, that is a layer 3 switch, because that layer 3, the Wi-Fi modem or whatever you have at your home is generally a layer 3, because that have a layer 3 property, routing property as well, and that can also have your layer 2 conditions like connections with Wi-Fi or the direct cable connection. So this is three type of devices to create a network. Okay, now we have more devices. So just like we have routers, layer 3, layer 3, this is basically a network devices. Now there's one more device which is for security. Security is just like firewall. So firewall, what happened? Like in firewall is like to prevent the unauthorized access. Like in case if some source IP address wants to connect to some destination IP address, and you want to restrict it, you want to tell, okay, you can't access it, then you just need to use a firewall. Firewall have more properties, not only, so firewall is also a layer 3 device. So if somebody asks you, okay, what kind of device is a firewall, you can say it's a layer 3 device. But now these days we have next generation firewall that have layer 3, layer 4, layer and other application and other layers also we can make. But mostly the firewall deal with layer 3 and layer 4. Layer 4 I will tell you next, because that will need to be have more discussion. So next gen, so firewall is just like a router. You think just like it's have the router don't have that much property, or to have let the communication to be blocked within source and destination. It will just check its routing table and okay, find the path to send the traffic. If do not find the path, drop the packet. Two things the router can do. Now router also have access list. Router can also have a access list. So how firewall works? Firewall maintain a just like a router maintain a routing table, firewall maintain a access list. In access list, source, destination, and other things will be given. And based on that, your firewall make the decision. Okay, I need to allow this communication or not. So just like a this is just like a security guard. a guy who wants, who always check and will, will let you in when the traffic or when the communication is legitimate by a administrator given to their device. So that is a firewall. Similarly, this is also a network device. Similarly, this is an access point. Okay, so just like at your home or maybe the college, you want to access the Wi-Fi network. So for accessing the Wi-Fi network is the first approach. It will be to connect to the access point. Access point, what will do? It will create a wireless network for you. Okay, and what it will do, it will just radiate some wireless signals so that your mobile phone or the wireless or the Wi-Fi adapter can receive it. And once it will receive it, it will tell you, just like my laptop is receiving here. If you can see, it is receiving one signal, geo fiber. So this is a Wi-Fi. This is I am receiving from my access point. So this is the access point. So once you receive it, you will try to connect it. This access point will the first layer, or the will let you connect user to the network. So this, just like this is the access point. So consider this is a scenario where you have a new. So think this is the access point. Okay, I will just create a network. This is what we will say. This is a AP access point. Okay, now this access point will further connect to a switch. So I'm just creating how the communication will happen. Okay, so this is the access point. Now this will connect to a switch. This we will say, okay, this is SW. This is a switch. Now this switch will have the connection with a particular with a router, which is a layer 3 one. So we will make it like a bigger one. So this is, we will say, okay, this is a router. Okay, now this router will have a connection with a firewall. Firewall will to produce the security. So router and firewall is mostly our edge devices. Okay, this is a firewall. Now this firewall will connect to a network. We will say it's an internet. Okay, now again the same network. Okay, now the same network is another side of the world. Okay, so is also connected to internet. Okay, now one user, this is one user, we will say you as a user, and wants to connect to this another user, which is here. So what it will do, it will first connect to the access point. So there's two way. So if we want to go for wireless, it will go for AP access. If we want to go for a LAN connection, it can direct connect a LAN cable to the switch, right? You can have a direct connection, a LAN cable, a Cat6 or some cable you have. So now it will give the packet to the switch. Switch will give to the router. Router will give it to the firewall. So firewall check whether it is allowed or not. Okay, then it is allowed. Then it will go to the internet. Internet, again, there is one more file with another user. It will allow or not, it will decide. Then it will go to the router. Router will give to the switch. Switch will give to the AP or then the user. So this is a communication which is happening. This is a one. Similarly, this guy will respond. So this guy will give to his AP access point, then give to switch, then a router, then a firewall, then an internet, then a router again, then a switch again, then an access point, then again it is. So this communication will need a lot of configuration on access point, on the switches, on the routers, on your firewall. So these particular things a network engineer manages. That's why I want to tell you about these devices. Then now you know your use. Okay. So you understand it, right, Roy?
Yeah, I'm still watching. So
Yeah.
so I understand the user, and
Mm.
the access point is like
Mm.
what is the access? Is the access point a physical thing, or is it like how you showed for the Wi-Fi?
Yeah. See, it's a physical one. Access point mostly is a physical. Your switch can be a logical. It can be, see, I will tell you, there's a virtual switch is there and there's a physical switch. There's always your devices have two categories. One is physical, one is logical. One is virtual.
Okay.
Virtual is means somewhere maybe you have one server, okay, or may and your server there you will have a virtual machine concept. In this virtual machine, there is one router as a machine is running. So that is a virtual router. That also exists, but mostly in a LAN and other scenario, mostly we deal with the, but in case of data center and bigger network, we go for virtual one. But in case of a small area network or LAN kind of condition, we mostly we deal with physical one, because purchasing a server, then installing the router, and then using it, and then having more connectivities is not a very easy job, and that would need another kind of specialization. Okay, so that is, I will tell you, this is also part of CCNA. Huh? So yeah,
Okay.
so AP basically mostly APs are physical devices. Okay, it
Um,
will always. Hmm.
do we
So
know do we
yeah,
know what
go
it
ahead.
like? For example, I know what a switch looks like because you connect to the switch, and I
Mhm,
know a router, you connect to a router, and I know you connect to, of course, the firewall is
mhm.
probably the
Right,
software.
right.
But what does the AP look like physically?
What is what is the access point looks like, you are asking?
Yeah, you said it's physical, right?
Yeah, this is the AP. See, this is a Cisco
Okay,
AP.
okay, yeah, okay, got it.
Maybe you have seen this in many places. This may be in the malls. This may be in the schools. Everywhere you can see this. This is the access point.
Okay,
Cisco
got
access
it.
point, right?
Hmm.
So this is called Cisco access point. Now Cisco access point. Okay, so now this access point is not the only access point which is capable of providing the services to a big campus. So this will have 10 or 20 meter of radius. This can radiate a signal within 20-30 meters. Okay, after 30 meters, you need to have one more AP. You got it?
Mm. Hmm.
Then after that 30 meter, just consider a shopping mall, a bigger shopping mall. There, a one single AP is not sufficient to provide the wireless network, right? So you need to have more AP. So that those are actually, there are multiple APs are kind of working simultaneously to provide a wireless network. And those access points. So now the terms comes to you, how this AP will be configured. You need to configure it, right, to provide a particular SSI. So just like I'm getting here, you can see here, I am getting this geo fiber second CT 5 gigabit ST. This is a SSID. This is
Okay.
this is this is so I'm getting from my AP. So this needed to be configured to AP, right? This is needed to. So for configuring this AP, we have wireless LAN controller, WLC. So what happens? See here, this is picture is there. See, this is LWAP, lightweight AP. AP is just like access point. So this access point, this is AP and lightweight AP is the same thing. Okay. So this is a AP. This is connected to a phone. This is connected to a tablet. This is connected to a PC. Now this is connected to a switch. Now there is two computers, one more switch and then router. Then there is on the side, you can see there's one device, which is WLC, wireless LAN controller. This WLC is no use to a user, but this is for you. This, from by logging into this WLC, what you will do, you will configure this access point. You will give the required configuration to access. That is a WLC, wireless LAN control. Even in WLC, not only configuration, you can monitor. You can monitor how many users are connected to a particular access point. Is there any particular problem to the access point? Any alarms is generated to on the access point? So these kind of activity, basically you will monitor from a WLC. So WLC is an administrator device. You need to manage WLC. No user, there is no use of user, no user access to WLC. You as an engineer will log in and try to manage the WLC. Okay. So
Hmm.
there is one more device you need to learn is WLC, which is wireless LAN controller. What is the need of wireless LAN controller? To manage the access points, to configure them, to monitor them, to give them the configuration. So that is your controller. Okay. So that is WLC, wireless LAN controller. So this is just like this is a single, okay. So now, so this is also having, now this is only a simple small area, right? But now you have more than one WLC. So you have multiple WLCs, right? Because it's not like you are having a single small area network. So you will have multiple. So for that, Cisco provide DNA centers. So those DNS centers, what those DNS, they will just have all the WLC with a single access. And now you do not need to log into each area WLC. You just need to log into DNS center directly. And by logging into DNS center, you can manage your all area WLCs. So it's a centralized managing device for all the WLCs or wireless LAN controllers. So like you say, think about, you have 5 different destinations in your city, all are having Wi-Fi access, and you need to configure up a till. So every time you what you think, you will go to each of the each of that destination and then configure it. So it's not a scalable solution. So for that, we have DNS centers. So that is a centralized point, just like maybe it will be running at your office, or maybe it is running on the cloud. You will just access your DNS center and then configure your access points. Okay. So that is a centralized manager. That is, we used to say controller. So DNS center will have more than one WLCs to be managed. So that is also that is a Cisco DNS center we have. Okay, so this is, see here written, they act as a central point for the configuration, security, monitoring, wireless network, simplifying the management and improving the overall performance. Because now you do not need to go to each WLC. You just need to have one DNS center to manage all your WLCs. So now that's how it will be. Now, next thing is endpoint. So endpoints are physical devices, just like computers, laptop, printers, phones, tablet, basically a user device, which is connected to a net. So this is endpoints. Now we have servers. So servers are basically just like your computer. Okay, so computer have storage, right? You have networking. Computer can do networking. It can do storage. It can do computing. So these resources is available on server. So just like a computer have 1 TB or 2 TB, this server can have more than 100 TB of the resources. So this can provide you the storage. This can provide you the computing stuff, just like in case if you want to create a virtual machine on the server, then just like create a Windows machine. So just like we have a laptop, it can have more than 100 laptops in a particular server, and different user can access and use it. So that is a server, because a Windows machine need CPU, memory, RAM, right, and other intelligence to perform the activity. So for that, a server can have more than one Windows server. So, or Windows machines. So just like having, so what happened in a bigger scenario, it's not like the only one application is, there are more than thousands of applications are running on different virtual machines. So this server will carry different virtual machines, and those virtual machines will have the applications, just like Windows, Linux, Mac, everything they can have. And based on that, this server will have more than one machine. So that is called servers. Okay, server is basically storage resources, power apply, everything they will provide to you. So Cisco have this server named as a Cisco Unified Computing System, UCS. UCS is kind of server. Okay.
So you
Now,
could have
yeah,
so you could have
go ahead.
endpoints that are single machines, or you could have
Mm,
servers.
right. So yeah. So endpoint is a single machine. So it's basically access to, from which you got the access to the network. Just like if you want to
Mhm.
connect to the internet and want to browse something, go for a shopping to Amazon, then you need a mobile phone or laptop or a tablet, right? Then only. So that first layer of device is end, from where you just start connection with the internet. So that is endpoint. Then we have a server. So server is just like having more than one device in a particular. So it's just not like it may have thousands of machines running in a server. So that we used
All
to
right, so
say
let me ask
virtual.
you a question. Do you
Yeah.
have to connect an endpoint to a server?
No, direct, yeah. See, so so for those endpoints, I've seen a scenario just like a Facebook. Okay. Facebook is having servers somewhere running in a data center. You just log into the Facebook with a browser. So what you are doing, you are connecting your endpoint, using your endpoint and trying to connect to the Facebook server. So yes, but it is not directly connected, right? You have an internet between your server and your endpoint. So yes, the endpoint is connected to the server and it is needed to be connected. And that's how, and those connections is basically done by the network engineer. Okay, so this is an example, a Facebook server running somewhere in the world. You just get a browser, get access and connect your endpoint device and use that endpoint device to connect to the Facebook. But that is a server. Facebook having servers. They are running some application in a different so that they can maintain the database of the users and they can make it the interconnection. They have programmings and other applications to be configured on the server so that you can get the access. So yes, endpoint connect to the servers, but not directly. Anything else?
No, I'm good.
Okay, so yeah. So now this is PoE scheme here. So what is PoE? PoE, just like a wireless, don't need a cable, right? You just have a Wi-Fi connection and wireless things are happening. I will tell you because the wireless is also part of CCNA and how we have this is a wireless connections, we'll tell you. So now there's a PoE. PoE is a cable. Okay. So what happened these days? See, there is one device without any power connection. So that device is not needed to have a power connection. Okay, it just not it is not need, just like think about this is a AP and this AP do not need a power adapter or power connection or a socket to be connected to this AP. So in that condition, this AP needed to be needed a power, right, to run the services. So for and also it is not convenient to have the AP to give the power with a power cable or something, or you just like it will be add a extra cost to you. So you just need to run one power cable and then one LAN cable, right? One LAN cable to connect to the switch and one power cable to give this AP a power. So it is not a convenient method or scalable solution. It will cost too much when you have more APs. Maybe you have 1000 AP, then you need to run 1000 power cable and 1000 LAN cable, right? That is not a scalable solution. So in for that, what thing is developed is power on Ethernet. So a LAN cable, a LAN twisted cable can have the data communication and power communication, power as well. So two cables, two pair of cable will use to transmit the data and one is for receiving the data and two cable will be used for providing the power to that end or the access point or maybe the switch or maybe the some device or the network device which does not need to be have a power adapter or power connection separately. So one single cable, two solution. One is for data communication, another is for power supply. So that is called power over Ethernet because Ethernet cable is giving power to that device. You got it?
Okay.
Yeah.
The Ethernet is giving power to everything.
Yeah, so that is a kind of Ethernet cable, a LAN cable, right? Which I have shown last in a last call, a simple LAN cable. Yeah, right. This is a LAN cable. See, you've seen a blue, this four pairs, 1, 2, 3, 4. So two pairs we are using to provide the power and two pairs we are using for data transmission. So that is PoE. And mostly these days we have PoE, power on Ethernet. In a in just like in a campus network, you want this AP to have the connection with switch. So this access point will have one that cable, this power PoE cable connected to this. There will be adapter here. It will be inserted here, then connected to the switch. So switch and this, then there is no power. Power, another power source needed to given to this access point. Switch will have its power. Okay, switch will getting a power from a power source, but this access point do not need to give the power. It will be running on the PoE. It will get the power from the switch to this guy. The switch will give the power to this AP and access point will be switch on. You do not need to give additional power source to this access point. So that is called PoE, power on Ethernet. So we are getting two solutions. One is to power, one is to data transmissions. Okay. Now, now this is the devices are now completed. So now how to connect the devices? So there will be some architecture, some some method to connect that. So for that we have tier 2. In tier 2, what happened? There is a collapse or distribution. So one switch, one core switch, and this is basically a L3 switch, which can have LAN and layer 3 and layer 2 services. And then tier 1 access, which is only having layer 2. So that is called two tier. Only two tier is here. Okay. So this is a layer 2, this is a layer 3. And then this layer 3 will further connect it to a router. Similar to this pattern, you can see this is the access layer switch, which is connected to AP, right? Then this is a R, which is written here, is a L3. Consider this is a L3. So now you have two tier. One is switch, another is this. So now multiple user can connect to this guy, this guy, this guy, this guy, this guy, and can go to the internet. So this is a tier 1 and this is a tier 2. This is basically a a tier 2 condition. Why we have this kind of scenario? So think about this device, okay, where my cursor is, went down. So if this went down, the another one will provide two services, right? You can see here, if this went down, tier 2, because this is our core network here, and this went down, then if it is a single device, then there will be no further communication. All the user will lose the access. So in that condition, we have this condition, or we have some configuration, so that in case this went down, this will come to the picture, or this will be condition where this will become a standby and this will be active. So active will provide the service, this will become a standby. When this went down, this will take care. Or in the same scenario, this went down, this will take care. So two devices to maintain the redundancy. So this is the tier 2 net, where we have tier 1 means the access and tier 2 as a core distribution. Similarly, we have tier 3 as well. Okay, so tier 3 is like having same thing. So this access layer is L2. Tier 2, we have a L3. And then with tier 3, we having core, that may be the router, a bigger router, to having more connection, more capacity to the users. So tier 2 will have distribution. Distribution means they will distribute the packet actually to the access. And core will try to connect to the WAN or the different network or the internet. So this is the core. So this is also a deployment in a particular network scenario, which is mostly in a data center. If you log in, you will see this kind of scenario where you have tier 1 to connect to the access point or the endpoint, and then you have access to the layer 2 switches. Then you have a distribution switch, which is not interconnected. You can see here in a tier 2, tier 2 core and distribution is collapsed. They are one. They are having between them there is one cable to maintain the redundancy, right? But here the redundancy part is maintained by tier 3. There's a separate core, and then distribution, and then access. So this is 2 tier, this is 3 tier. So this is a characteristics of the topology. So this we used to say topology of the particular network. So one is this, one is this. Similarly, there is one more. Okay, one more is the spine leaf. So what happened here? You can see there is an interconnection between this core switches, L3 switches. Here you can see in the core and distribution is the collapsed layer. Here are interconnection. But there's one more which we used to say is a spinal leaf. So a spinal leaf is what happened. One layer will become a spine. They do not have interconnection. And another one will become leaf. They also don't have interconnection. They only have, each of the leaf will connect it to a spine. So this one leaf will connect it to this spine, and this spine. Similarly, this will connect it to this, and this. See, so switches are not interconnected, okay? And leaf or spine are connected. So they don't have interconnect. So this is called leaf and spine architecture. This is actually to provide the direct services. So see, this server wants to talk to this last server. So now this server will go to this switch. This switch will go to spine, and spine is directly connected to this switch, and then so there is no further communication needed to have another switches or another spine. Direct connection. This is called ECMP, equal cost multipath, because we have multipath, but all are equal cost, because this server 1, 2, 3, 4 path, right? This server 1, 2, 3, 4. This server 1, 2. This server is here. It is connected 1, 2, 3. So like that, we can see here we have only two same path for each server to be have the interconnection. So that is called leaf, and that is called spine. So spine, why we have this kind of scenario? To have the equal cost for each and every devices here. Okay.
Yeah, no, I get it. I just gotta try to
Yeah.
memorize when I have time all the different
Yeah. So
topologies
yeah.
that they
So
have. Yeah.
basically, we have this. So in case we have three topologies, basically we deal with these three topology normally. Okay, like this guy, which is in a small campus network. This will be in a data center. Now, mostly data centers are migrated or the upgraded. So now they will have this. Okay.
Okay.
Yeah. So now this is upgraded one. This is mostly uses in a data center now. And now whoever using this kind of technology, they are just migrating to this because this will provide equal cost and this will have more features. Okay. Basically, this is a spine leaf and this is developed by an engineer named Klaus. So that is also called Klaus, CLOS, Klaus, also named as a Klaus topology. So then we have a cloud to be understand. That is also a cloud. Cloud is a network, just like we are discussing earlier, that is basically for a virtual machine. So data center have more than one servers. So just like here, this one server having 10 or 20 or 50 Windows machine, a data center can have thousands of Windows, Linux or other machines running in a data center. That is, and that is a data center. So now there is a cloud. Okay, so cloud is just like a user which can develop an application on Windows machine. So that user will become your client and he asks a cloud provider or the guy or engineer, okay, I need a virtual machine, a Windows machine. So what you will do, you will just log into your network and then try to, there's a cloud, there will be some application, some browser you will log in, and then you will create a Windows machine and give it to that user and tell that user, okay, this machine you can use for the communication or for your application development or whatever you have the use with or something, so like that you can have. So that is called a private cloud. Cloud is just like private cloud create a service inside a company. So private cloud is basically this kind of network or data center where a particular thing, just like a company which is developing more than thousands or of application, then it will consider to have a private cloud. Then it will develop and own and managed by that own company. It is just like everything which is in that cloud, just like a data center, maybe the servers and and other devices, just like switches, routers, and everything is maintained by that single company. That is a private cloud. There is no access to other guys. Just like me sitting in a different world can't access. Just like a hospital private network, you can't access that. Maybe because of that is running on a private cloud. You do not need to go. You are not allowed to access to that because of that, because they have their own users, they have their own employees to access that and use that particular network or cloud to have developed their own application, which user do not. User can also, you only can have the use. Or maybe if you go to the hospital, you are go to the hospital, they will take your data and will feed it to the cloud, they put in on their private cloud and then use it. So you do not need to go, and don't have the access to the private cloud. So that's how the company which create all the things in with their own to have the servers and the space, power supply, everything will be managed by a one single company. That would be a private cloud. So
So
similarly,
is that
yeah,
is that
right.
similar to is that similar to Salesforce?
Yeah, you can say, yeah. So it's just like a Salesforce, a company, or some organization which have their own. Just like if you go to a company, you just go apply
Right.
for a job, yeah, and go to that company, and that company have their private cloud. So it will not given to any other else. Oh, okay, maybe after creating application, they have some team to sell that application, and then that application will be given to the users. Right. But before that, everything is happening inside your company. So nobody, no other guy can have access to. So that is called a private cloud. But in this scenario, what happened? Everything is managed by the company itself. They need to pay for everything. They need to purchase. They need to manage the guys, employees, and everything for this maintaining the private cloud. They need to hire network engineer, server engineer, and there are other guys, sales and other guys, or the power they need to purchase. They need to purchase the space and all to develop this data centers or their private cloud. So that is called private cloud. This is on-prem. That is, this is called on-prem. Their on-premises is there, right? So that is a private cloud. Now, so this is similar. Now, this is a private cloud owned by. Now these days, what happened? There's a public cloud as well. Public cloud means just like Amazon Web Services, right? You know, Amazon, the AWS. So as a company, if you have a startup or some company, you do not, and you do not have that much that much capacity to maintain or create a private cloud, you can ask Amazon, okay, Amazon, I need this much configuration or this much space, just like 100 TB of space I need, 10 CPU I need, and 12 and this much memory I need, this much storage I need. That's how you can tell to the public cloud provider, that just like AWS, Amazon Web Services, Azure for the Microsoft you have, and for Google we have Google. So kind of you can say, okay, this. So you can just ask, and then they will create everything for you. You will just sitting on your home and developing it by connecting to the internet. So they will provide you particular zone for a web browser or access, and they will create it for you and then give it to you. So that is a public cloud. You are not managing the infrastructure. You are, or the company or the user are only having the access. They do not need to think about whatever running inside that data center, their machinery, their engineers. All the things will be managed by the AWS. You just need to access it and work on that. So that is a public cloud. So those clouds are running on the as a service model. So as a service model, so these, just like a public cloud, will run in this model. The first is called IaaS, infrastructure as a services. So infrastructure as a services means it will give you one infrastructure, just like number of CPU you will need to provide, storage you need to provide, memory you need to provide, and everything whatever you need. Your engineer says, okay, this much we need to create a virtual machine, then you will give it to AWS. They will provide you that much infrastructure to you to access, and then that you can use to create a particular application. You can use it for your deployments. That is a IaaS, infrastructure as a service. Similarly, software as a service. So think about, we are having Microsoft Outlook, right? We have Outlook to mail, Gmail, Gmail. So
Yep.
maybe Gmail is a software as a services. You do not need to, you can't make it, you can't develop anything on a Gmail, you can't make any changes on a Gmail. You can access it somewhere from the world as a software, and you can send and receive the emails. Right. So that is software as a services. That is provided by Google. So you do not worry about the infrastructure, how much memory, how much. So they will give you, okay, 15 GB you can access. So now you can have the free 15 GB, 15 GB of the data storage, and that you can use for the sending and receiving the email. So that is a software as a service. Similarly, we have one more platform as a services. So in platform as a services, what we have, one more feature we have, with this is similar to infrastructure as a services, but one more thing which we have, just like there is a requirement for a particular software. So you get the infrastructure as a services, you develop a Windows machine in infrastructure as a services. Now to developing something or to create some application, you need one software or one tool. So that tool you need to purchase, or it can be provided by a cloud provider. So in case if you get a tool or some application running on an infrastructure or running over infrastructure as a services, so that is a development tool maybe. So that is called platform as a services, because now you not only get a Windows machine to generate a vision Windows machine, you also get some tools to develop your application. Right. So that is also called a platform of services. So this is the three services on which cloud runs. Okay.
Mm-hmm.
You got
So,
it? Yeah. Go
yeah.
ahead.
So the thing is this, right? The software as a service, you say something like Gmail or something that
Right.
they provide you and you just use it. Development,
Use it.
development
Yeah.
gives you access where you could actually develop and create more on it. And
Yes.
infrastructure as a service is
Mm.
like, I
It's
guess,
like, mhm. Go ahead.
is it like Wix? Is it like Wix to create a website where you buy the space and they give you some software ready for you to use. It's already
That is your
created.
platform. That is your platform as a service. Just like you want to create a website. So for
Right.
creating a website, you need a tool, right? You can't just go and log into a Windows machine and can create a website. You need some application or some tool to create a website. That will be your platform as a services. Okay. You just get an application. That application you will access somewhere in the world. You will create it, and save it. That will be your platform as, because what they are giving you some tool to develop, a platform to develop your application. So that is your third. Third will come is the infrastructure as a services. See, you already have tools. Okay, so see, one vendor just like a Windows. So a tool which can run over a Windows. So now that tool you purchased. Okay. You do not want to go to a cloud provider and ask for that tool, or maybe it is not available. Okay. So think about a tool which is not available to public cloud provider. So what you will do? You need some platform to run your tool to develop some application, right? So in that case, what you will do, the tool you purchase from somewhere else, and then you will purchase an infrastructure as a services. There you will get more CPU, more memory, more storage to develop your operating system. You will develop operating system on your IaaS, then use that particular tool, install that particular tool to the IaaS services, and then use it for the development of a website or an application or some other uses. So now you are understanding, right? And sometimes a public cloud service provider can give you some software, some tools. So in that case, you do not need to purchase with another vendor or go for another vendor to purchase it. You can get it from the public cloud provider. So then you will use as a platform as a services, because this is already given to you. So that's how. You got it?
Got it.
Yeah. So that is a one. Now, okay, so this is now the basically equipment and topology. Now we will go and learn this the cabling, okay, which is very important. So the copper cable. So basically we have two kind of cable. One is copper cable, another one is fiber cable. Okay, so copper cable is just like a cable which I have shown you, RJ45 with a RJ45 connector. They have different category. So they are basically unsealed twisted pair. Okay, so this particular is twisted pair. Why this is called twisted pair? Because cables are twisted with each other. So there are total 8 number of pair we got. Okay, total sorry, 4 pairs. So 4 number of pairs. Total 8 cable is there. So UTP cables are there. So they are physical mean to send the data uses electrical signal. So what flow on these cables? Electrical signal. So on what is the connector? RJ45. Both the side we have RJ45. That is we used to say pin out. Pin out means the connection on the RJ45 connector. So that can be straight through or the crossover. Straight through means when the RJ45 have numbering 1, 2, 3, 4, 5, 6, 7, 8 like that. So 1 is connected to 1, okay, and 2 is connected to 2, then it will be straight through, directly connection. And crossover means that one is connected to 3, 2 is connected to 6, 3 is connected to 1, like that. So there's a crossover here. So because why we have two conditions? Because of the uses. So straight through is basically for a computer connected to a LAN PC, sorry, the switch, then it will be straight through. Why will this will happen? I will tell you. Because see, consider the condition where 1 and 2 is here, 1 and 2 here is a TX transmission. In this side, in the left side, 1 and 2 will have the transmission, and here in the next side, 1 and 2, okay, 1 and 2 can be have the receiving. Okay, similarly, so 1, 2 can transmit here and the here as well, because this is the same condition. So same cable. So here 1, 2 is transmission, here also 1, 2 is transmission, here 3, 6 as a receive, and here as well 3, 6 as a receive. So 1, 2 here is a transmission. So here should be receiving, right? 1, 2 here should be transmission. So then the left side, it should be receiving one, because it will transmit. So this side should receive. And similarly, when this side transmit, this side should receive. That's why we need to twist the cable. We need to cross over the cable. 1 should be connected to 3 and 2 should be connected to 6. So that this TX transmission can be connected to the receiving point of another end. This is always between the switches, because switches ports are like that only. So whenever a guy, a technician you need to tell, okay, this kind of cable is between two switches. So you need to make it as a crossover cable pin out, so that this guy will understand, okay, the the left side of the cable, the 1 and 2 should be connected to 3 and 6 of the another side of the cable. So this RJ45, that's how the cable crimping will be done. So crimping is just like to insert the cable and press the cable with a 2. So like that, this will happen. Okay. So this is RJ45. It is RJ45. 1 is connected to 3 because it's a crossover connection is there. So if you see here, this is a switch. This is between the switch, you can see crossover. And this is between Ethernet's straight through. Straight through means 1 and 2 is connected to 1 and 2. And 3 and 6 is connected to 3 and 6. Because why? Because PC side, the 1 and 2 is a TX. And in a switch side, 1 and 2 is receiving side. 1 and 2 here is always RX. So here, and then 3 and 6 will be here, will be transmission. So in here, the 3 and 6 will be receiving point. So 1 and 2 on left, 1 and 2 on right. That's why it's connected, and that will be become your transmission and receiving. Receiving on pin 1, 2, transmitting on pin 3, 6. So here you can see that's why it is happening. So because of the uses and the application, we need to have two categories, crossover and straight through. Okay, so that is a copper cable. There's only two type of crossover and straight through. Any question?
Yeah, so the straight through is 1 and 2 connected to 1 and 2, 3, 6 connected to 3 and 6. But in the crossover,
Right.
the 1 is connected to the okay.
3 and 6, yeah. Because this is a cross connections, right? The one, your transmission is needed to connect to receiver point of the device. So because see, there is 8 pair. So and in a mode we want each cable can transmit one signal. Okay, or once it is just like one transmission port should not receive the transmission port only can transmit and receiving port can only receive. It is not like one port can do both for you, or one port is there, but there will be different pin on that. So one pin can transmit, so it can only transmit, it can't receive any packet. Once it will be not it will be make it like that, the transmission will always be transmission and receive will be always be receiving. So that's why we have this kind of condition where 1 2 will be transmission, 3 6 will be receiving on another side. So when there will be a question, okay, where you need a crossover Ethernet cable, then you will say, okay, between the switch I need to, because the switch ports are like that only. So for connection the cable, you need to make this kind of crossover Ethernet cable you need to create. And for computer to switch, then I need to make a straight through cable. That's how you will need to create the cables. So when you were in a particular site or data center and you want to, based on the usage, you need to create the cables. Okay. So just like if you go to the office and your desk, if on your desk, if you find a cable, what it will be? If you go to the office, okay, and on the office, you found a cable to connect with your laptop. So what cable it can be? What type of cable it can be?
Wouldn't be the RJ45?
No, it will be RJ45 connector. Will be RJ. See, RJ45 is not, it's just like a connector. My question is, if you go to the office and you just have a cable, okay, then you can just insert on your computer. So what kind of pinout type it will be for you? It will it be a straight through or will it be a crossover?
So I'm watching the two. I'm watching the crossover and the straight through.
Mm-hmm.
And
okay, so see your name. Okay, so this computer, think about this computer. This computer is yours. Okay, you go
yeah,
to the office. This computer, you connect a cable. So see, that cable will somewhere comes from a switch, right? Like that cable will have another point, right? 2 points of the cable. So another point is always on the switch, right? So
right.
you will have a straight through cable. So the
Yeah.
technician will make a straight through cable to the office. It will lay over the cable each in every side of the your office, and then you will get a LAN cable hanging over your desk. You will just go to the office, connect your cable. So that cable is always a straight through cable. That is the
Okay.
application. And then when you go to the office, backside of the office, and you go to the area where switches are there and two switches are connected, then between two switches you will always found crossover Ethernet cable.
Got it.
Okay. So yeah, that's the application. Now See, this is a copper cable. So this copper cable has a limitation of 100 meters. This copper cable cannot be run more than 100 meters. Okay. So then in that case, how you will connect two different sites, maybe having more than 1 kilometer of distance. So for that, what happened? We have optical fiber. These fibers can be run more than 100 kilometers. Okay, it's not like there's no limitation to run a fiber cable. Yes, definitely in between the fiber cable, we have some modulation and some modulation we need to do so that the carriers will be not dropped, but we have the fiber cable. So it's just like a copper is a cable, just like fiber optic cable. Fiber optic cable is basically run over a reflection. So what happened, a light emitting light emitting equipment will be there on your port, and that port will transmit a light, and your communication will happen based on your light
Right.
transmission.
So the maximum for the copper is, you said, 150 meters.
For copper, yeah. But the copper is
50 or
maximum 100, yeah, 100 meter, 50 meters, and 100 meters mostly a copper cable can use. Then after, if you have need to have the connection, then you need to go for the fiber
yeah,
optics.
fiber
Yeah.
optics.
Fiber optics, and fiber optics are like two conditions. So fiber optics cables are two type, multi-mode and single mode. So multi-mode is actually nothing but you can have more than one rays or the light rays on the particular core. So see the pipe, the fiber cable is like this. So one core, one cladding, then buffer, straightener, and over. So this is a protection. Okay. So buffer and straightener and outer jacket are the protection for this core and cladding. So core is actually made by the glass so that the glass can reflect the light. And then cladding surface is there, just like we have mirror, right? So when we go in front of mirror, what we saw are our own images, right? So how it is generating when a light comes to our skin and then go to the mirror and then reflected back to our eyes, then only we can see our pictures, right? That's how we saw our images on the mirror. So similarly, a light will be reflected inside. It's very small diameter, millimeter in diameter, and then it will be inside. So for 400 meter, we can have multi-mode fiber. Multi-mode is like more angles of light can be tried, can be given to the particular core. So if you go here, multiple angles, right? This is one angle, this is another angle, there's one more angle. So more than one angle can be given. That's why it's called multi-mode fiber. Similarly, we have a single mode fiber. So if till 400 meter, we can have multi-mode fiber. But like more 400 meter, then we need to go for single mode fiber. Single mode fiber is only having one laser, one light, one angle light directly given to that core, and it is running over that. So cladding surface is there, core is there, and then it is directly running. So that is single mode. Single mode is just like to transmit a light into much smaller core. A laser based transmitter send light at a single angle. Based on the angle, we decide it is a multi-mode or the single mode. So there are two types, single mode, multi-mode fiber, and this is also. So for more uses, just like for uh, more length to cover, we have this kind of fiber. So two type of cables we have, copper cable and optical fiber cable in hand. So that is done also. Now we have connection. So Ethernet, shared media, point to point. So yeah. So this is actually connection. Connection is like, okay. So as I told you, so now condition is like, okay, I will tell you. So now you know the cables. Now you need to connect it, right? These cables you need to connect. So how you can connect? So it can be just like if you use you share media. So share media is just like in case if you are used to this share media is mostly not in use right now because mostly we use point to point Ethernet, direct connection. This share media is time where we are using hub and other devices which need CSMA, carrier sense multiple assist, collision domain, and other things to be needed to develop there. But that time you use a share media. Now we don't have share media. We only have point to point. So the cables are directly connected to the switch. This fiber cable, this LAN cable or fiber cable is directly connected to the switch, and then that switch will take your traffic to the internet or other destinations. So the point to point is decided connection between the direct dedicated connection between two devices. So one point, another point. How it works? Data is transmitted directly between two devices without interference from other device. So no other devices is connected. So there will be no collision domain, no other device, no direct. So direct communication will happen. Okay. That so there is two category. Okay. So what happened, like how it is work? So full duplex and duplex. So there is a duplex. Okay. Duplex is means uh just like consider there is a walkie-talkie is there, right? So walkie-talkie, one at a time, one guy only can transmit and one guy only can receive, right? So that is called du half duplex. Like at a time, one guy can transmit, another guy can't only receive it, right? Only receive it. So that is that, but that in current scenario, it is not a good application. We need same time communication. At a time, we can transmit and receive both. So for that, we have full duplex. Full duplex is one particular channel to transmit, one particular channel to receive in a particular media. That is called full duplex. Okay, so this is point to point with full duplex. In that way, in that condition, we can have direct communication. Like both the in the same time, we can talk and we can also receive the messages. So that is called full duplex. So duplex is a mode of that. So we will see further like other things as well. So this like example is a connection between routers in a network, dedicated connection between buildings, connection using specialized equipment for high speed transfer. So that is actually called point to point connections. Okay. And then we have other advantage because we have dedicated, so higher speed, no collision, dedicated bandwidth, improved security due to private. So everything we have. This cost is higher because it's a point to point. So you need to dedicated media, need to create dedicated media and other things. So that's why its cost is higher. So that you need to take. So that is actually Ethernet shared media and point to point connection. Okay. Yeah, so similarly, if you have connections, then after connecting this, you have the connections, this cable and this interface. So each interface have one cable, then that cable can have multiple errors. So like in case if somebody says you, okay, my laptop, when I connect to that particular port, my laptop is not able to connect. Then you need to find out why this is happening, why this is not able, why this guy is not able to connect his laptop to that particular computer. So in that case, how you will find out? You will log into that switch, this switch, and you will check, you will run one command, show interface, the name of that interface. It will give you this much detail. Based on that, you need to understand what is happening. So the runt is frame that did not meet to minimum frame size requirement. So there will be frame size. I will tell you, this is actually, this is, I will tell you after I will tell you the frame size. Okay. So this is actually an interface cable issue. So I will tell you that. So yeah. So this is a hub, which I already told you. This is a collision can happen. This is another dwight breach, which I already told you in starting. This is a bridge, which can have two collision domain, right? Then there's one more device. You can say a switch. Switch will create, each interface will have one collision domain. So one interface, one collision domain. This guy on this guy. So there will be no collision because this will send and receive, because this cable will have full duplex. Full duplex means same time this can transmit and receive the packets. Right. So this is one domain. This is also a full domain. This is, so this switch will create a single each interface will have a one collision domain. Okay. So this is collision domain, which I already told you in starting. So this is, and if you see on the network, how the domains will be created. So if I ask you, this is a hub. So hub will have only, all the interface will have one domain. So one single domain, right? See the all here, if you see on the in the color side, you can see all are having one single domain. Then you have a bridge. So bridge can have, each interface can have one domain, one collision domain. So here one domain, one other domain. Hub is can have one. Then router, similar to switch, router can also have one domain, one collision domain, and each interface, which can also have same. So here you can count one, because this is hub. So this is total one. This is two. This is three, four, five. Five collision domains are here. Because hub can have one collision domain. Everything can be collide here. Then you have bridge. Bridge can separate your collision domain. That's why we have two here. Hub can then again have a single. The router. So here you can see one, two connected to hub. So hub two interface, then one collision domain. Here as well, three interface, but one collision domain. You can switch two interfaces, but two collision domain. Okay, similarly routers. Router and switches are same to the collision domain. Similarly, we have broadcast domain. So broadcast domain means a switch can transmit the packet. So this is this we have one more slide to complete. Then today's we have for today we are done. So so for we have broadcast. Broadcast means this switch can to find out to find out the destination. This switch needed to broadcast the packet or some if a packet is transmitted to the switch to look for a destination in a first when before creating a MAC address table, okay, or before generating a MAC address table, this switch need to find out the destination. So what in a first first what this switch will do to generate the MAC address table or the table to create a table to have some technology to find out the destination, it will broadcast that packet. So the switch will broadcast can broadcast to each of the interface. So that would become a broadcast domain because switch interface, each interface, a switch needed to broadcast the packet to find out the host, the destination host. That's why switch, just like a hub can have a single collision domain, a switch can have a broadcast domain. Okay, so broadcast domain, which switch will generate a broadcast domain on each interface. So that would that list of the interface will become the part of your broadcast domain. So that is just to say broadcast. See here, there is one router, and router is like the same. Router can have a single interface broadcast, one interface, one broadcast domain. Two interface, two broadcast domain, three interface, three broadcast domain. So like that router, but switch can have one broadcast domain. Here you can see three interfaces are there, but have one broadcast domain. So there are how much here? Two broadcasts. One is here, one is here. Okay, so this is actually a broadcast domain. This is called a collision domain that we need to separate. That the question comes in a so exam and will give you this picture. Okay, and will ask you how much collision domain is here. 1, 2, 3, 4. You will get 4 options and it will ask you how much collision domain you have here. So by the application, you need to know, okay, on this switch, each interface can have one collision domain. I have 1, 2, 3, 4 collision domains. So your answer will be 4. You need to click on 4. If they give you this image, then you need to find out, okay, then there is one bridge. Okay, so bridge can have 2. So 2 is here. Then there is a hub, so it can have 1. So 1 is here. So 2 plus 1 is 3. Then here's one more hub. So then 2 interface. Then there's okay. So this can also have 1. So 3. Then you just need to add 3 plus 1 is 4. And then here, so you just need to add it. Based on that, you can create a collision domain. So one hub, then one particular collision domain. Bridge here, then here you can one more hub, so one, then total 2 collision domain. Then you can see here one router, then router and switch is connection. Okay, this connection also a collision domain. So okay, so 3 collision domain. Then switch 1 and 1. So yeah, okay, 1 and 2. So 4, total 5 collisions. So 1, 2, 3, 4, 5 collisions. So you just need to focus on the interconnection of the devices. Then you can find out how much collision domain can be given. Similarly, for the broadcast, you need to see on the connection between these devices. So whenever the connection is between hub, then one collision domain. Whenever this connection on the, just like one connection to the bridge, one connection to the, two connection to the PC, but this is hub, so one collision domain. Now we go for, okay, this connection is done. Now this connection, okay, we'll see, okay, this is hub. So hub can create one collision domain. So, okay, one and one. So two interface, but one, because this is hub. Hub cannot create more than one collision domain. So, okay, this is also. And the router can have more than one. So this interface and this switch can have one. So, okay, need to give the one number. Then this switch can have one PC and one PC more. So, okay, one interface, then one, because switch can have interface collision domain. So one interface, then one collision, another interface, another collision. So like that. We need to count 1, 2, 3. So this like it's a 5 collision domain. Similarly, for the broadcast domain is happening. Okay. So broadcast domain is just like a switch can broadcast a packet. Switch can broadcast to get the destination. So so that if you see here, switch can have 3, 4, and one router. So it will make a one broadcasting because this switch can broadcast the packet in this particular domain. This three device will receive simultaneously. This three device will receive one packet to get the destination. This switch in a starting will transmit packet this interface, this interface, this interface. Then okay, say we have one broadcasting domain. That's all. Okay. So this is how we deal with the domain, internet switching and collision and broadcasting domain. So that is also part of our switching because after connection to the cable, you need to get it how much domains are there. So this question can come based on the collision and broadcast domain. So you just need to give the answer. Then you have one more thing, which is duplex mismatch. This is the last slide for today. Then we will do rest of the slide tomorrow. So this is the duplex mismatch. Duplex is just like I tell you, what is duplex? Duplex can be duplex is just like a cable. Okay, this is okay. I'll tell you new.
Yeah, you said the duplex allows you to send and receive at the same
Right,
time.
same. So duplex is a method. Okay, duplex is a kind of a word which we give for a technology. So now there is one duplex. Okay, so see, there's two condition for duplex: half duplex and full duplex. So half duplex means one communication at a time. So if there is a half duplex condition on this device, okay, then if this two is connected, okay, then or think about this particular PC is connected and this is connected and this condition of half HF here and HF here, similarly HF here, every interface will have its own conditions to configure the duplex mode. So we always configure a duplex mode. So this is half duplex. This can only transmit at a time or receive. Okay, that is a condition. It can't receive in a single time. Just like maybe at 10:30, this can only transmit, not receive. And at 10:30, this can only, as this is transmitting, this can only receive, not transmit. At 10:31, this can transmit and this can receive. Okay, so this is a condition which is at a half duplex, just like a walkie-talkie, right? The children have walkie-talkie, so they need to click on a button, then talk, right? And when one guy is talking, another guy is only listening. He can't talk, right? And after that, another guy will push the button and talk, and the next guy will listen. Just like in army, they have a walkie-talkie, a wireless device. They just need to click on the button, and then they at a time they can talk or listen. But in case of phone, right, we can talk and listen. We can also talk. We can also listen. So that is called full duplex because at the same time you are talking and receiving. So in that application is called full duplex, where you are talking and receiving at the same time. So that is a difference. So that is here we can say duplex. So when you have a switch, as an engineer, you will log in and the guy will tell you, okay, I need to make that interface full duplex or half duplex. Okay, so you will go and just configure. Okay, so you will go to the interface and write duplex as a command, and there will three option will come: auto, full, or half. Auto means auto negotiation. Auto negotiations mean these two interface will have some communication with each other and will decide whether the communication will be half duplex or full duplex. Okay, so just like condition here, so manual settings can be done. So auto negotiation disable here. I can here see auto negotiation enable here. On the switch, auto negotiation is enabled, and on the PC, auto negotiation is disabled. So this guy not able to auto negotiate. Like this switch can send some message. Okay, what is your duplex condition? But this guy is disabled, so this guy will not tell and not reply to this switch. My condition is full, or my condition is half, or my condition is auto. Kind of condition this guy can't reply. So duplex you will configure. So just like between two switches, just like this is a okay, where's that switch? So this is a switch, and then one more switch is there. Let's go to this. So one more switch we'll create here. We'll have the connection. Okay, here we will give auto as a mode, duplex mode. And here we will also give auto. So now they will negotiate. Okay, and in negotiation they will try to find out what. So in auto negotiation, what happened? Always full duplex mode will be selected. If both will be auto, they will select full duplex. Full duplex means at a time they can transmit and they can receive. So there will be, this cable which is connected between these two switches will have one cable for transmission, one cable for receiving. So this will become 3x. This will become Rx. This will become Rx. Sorry, this will become here Tx. This will become here Rx. So this is full duplex. This separate cable for Rx, this separate cable for Tx. So they can transmit, right? They can talk because there is no one cable. One cable will be there, then there will be collision, right? This is also sending, this is also sending, there will be collision. So one, but the single cable, this is Tx, there will be no Rx on this. So that in that condition, we have full duplex. So auto negotiation can be done based on the configuration. So you need to set auto negotiation both the side. You can't set one side auto, another side non-auto. You just need to select auto both the side, and then they will have the communication and will try to fix and will make it full. Okay. But if you are going for manual configuration, then you also configure full both the side. So you can also set here like full. Okay, so this full and this full, then this device know, okay, my communication is full. So one at a time it will transmit, at a time it will receive. Okay, so this is a full duplex. And you also can set half duplex. These days, nobody set half duplex. Okay, this is very old kind of technology where people deploy because these days we have very we need more bandwidth and more we have very less time for the users to have the communication. So the half duplex is very old thing, but now I'll tell you, because half duplex you can set here, half duplex you set here. So here you can see both the sides should have same configuration. Okay, both the sides should always have same configuration. Okay, so you are getting my point, right? So the
Yeah.
device, yeah. So always as an administrator, you need to set same thing. If you are configuring auto, both the side it should be auto. If you are going for full, it should be full for both the side. If you're going for half, both the side it should be full. It is between the PC and switch, and it can between the switch and switch. Right, you are getting it. So it can between switch and switch as well, but you need to go for same, else it will be duplex mismatch. Okay, one side you set half, one side you set full, or one side maybe it's one side is auto, one side is a non-auto. Non-auto means this guys can't reply to the negotiation message for the switch, and then it will be a condition here. It is set it to be half, and it is the auto negotiation enabled, but it is set, but it is just like with this half, then it is full, then it will not able, then it will be duplex mismatch, and duplex mismatch will cause you will cause you speed issues, and it will also sometimes make communication faulty. It will just tell you, okay, I'm getting packet drops. The user will tell you, okay, I'm not able to send any packet to the destinations. Because of this match, the duplex mismatch, it will be a problem. So always needed to be set as the same for both these. Okay, so this is a duplex. Similarly, there is a speed. Speed is nothing but a bandwidth. Okay, so just like this is 10 Mbps, this is 10 Mbps. So you need to set the speed as well on the interface. You need to give 100 Mbps, 10 Mbps, 20 Mbps, or auto. Auto means speed will be negotiated. Just like this guy have 10 Mbps, switch have 100 Mbps. So the lesser speed will be selected. This will negotiate and will tell, okay, I need to go for 10 because I have 100, but my neighbor have only 10. So I need to go for 10 because 100 I can manage, but my neighbor can't manage 100 Mbps of speed. He can only manage 10 Mbps. So here, if you can give speed with the auto, then auto means the lowest value will be selected. Else you can give just, if you know, okay, this can also have 100 Mbps. My switch can also manage 100 Mbps. You can configure both the side as a 100 Mbps. So this is called speed and duplex. So duplex is a mode where you select. Now these days, only two type of configuration engineers do, auto or full. They don't go for half. Nobody goes for half. They can go for auto or full. And speed, they always go for auto, or sometimes they go for 1000 or 100. 10 nobody's goes because 10 Mbps is very less kind of speed. So mostly they go for this. So this is kind of a configuration you can say. And one topic is called duplex mismatch. Means one side is full, another side is or different configuration. One side is auto, another side is not non-auto. That is also duplex mismatch for you, right? So this is how a duplex mismatch. Okay.
So this is not between switches. This is between a switch and the computers that's connected to the switch.
Yeah. Yeah. So this can also be happen between switches. So in condition like this, I tell you, okay. So this is one switch. This is one switch. This is connected. Okay. Here, if you here you need to set this is here you need to set auto. Here you also need to set auto. You got it. This is also interface. Here also. So we are talking about duplex. So duplex is here you need to set auto, but here you need to set auto. Here you can set full. Here also need to set full. Else, if you see you configure this switch, you are set full. Here, if some other guy came and he set to half, then this guy will transmit at the same time and receive at the same time, but this guy can't, right? This guy only can receive. So only can receive at a time or transmit. So this is here is a full, this is a half. So duplex mismatch happen. In that case, what happened? Sometimes port will not come up. Okay. And sometimes if somebody transmitting a packet, that guy will say, oh, I'm getting packet drops. My packet is not getting transmitted to this particular destination. See, here one computer is connected. Here one computer is connected. This is a, this is a B. So this user will come to you as a network engineer. He will tell you, I'm not able to transmit the packet. I'm not able to connect to the B. Then you will log in and check what happened to that. Okay, you will see this interface is connected between these switches where this user is located. You will log in and will check, okay, my side it is full. Okay, so there is no issue that this, so what then this you will investigate it and say, okay, my speed, okay, this is duplex, which is full. Then you will log into this switch and check, okay, this is a connection to this switch. And but okay, then you will find, okay, I'm getting duplex. That's why this guy is saying this guy is not able to connect to B. You will just go to that interface, log in that device and go to the interface and make it as a full. And then after making it a full, okay, then you will ask, okay, now, okay, ask user, okay, now you will please check. Then you will again try to communicate to the B, and then you will able to communicate. Then A will say, okay, okay, now I'm able to communicate to the B. So then you will find out, okay, why this happened? Because of the duplex mismatch condition. One side it was full, another side is. So it can also happen between the switch. Similarly, this can also happen between this particular interface to this PC. Right? So see confusion here you said as a half. Hello, I'm audible?
No, I'm there. I'm hearing you.
Yeah. So here you set as a half. The PC is full. Here as well, this guy will tell you, oh, I'm not able to send the packets. Then you will say, what is your duplex mode? He said, my duplex mode is full. And then you will check on switch interface where this PC is connected. And you saw, okay, mine is half. I need to make it full. I need to make it as the same as a neighbor. So then you will make it as a full. Then it will. So this can be happen between switch to the PC or the PC to PC. So this duplex mismatch condition is between the ports, not the devices. So a device can have more than one ports, right? So this device can have 1, 2, 3, 4 port. This device also have 1, 2, 3 port. Similarly, this have cables, right? This cable, this cable, this cable, and this cable. Every interface needed to be configured as a same duplex mode. So it can be full or auto. Now you get it, right?
Yeah, so this is between ports, not devices.
Port. Yeah, this is between the ports. So always you need to, so that's why we are saying the interface. You need to manage the interface and you need to log in and check what is the duplex, what is the speed. Sometimes user also report, I'm not getting speed. I'm getting only 2 Mbps of speed, but your link is 10 Mbps. So you will see here it is 100 Mbps. Here it is 100 Mbps, but this speed is set it to 10 Mbps. Right? So this can manage, this can have 100 Mbps speed, but this interface can't have 100 Mbps. This is only 10 Mbps speed. So you need to tell user, I don't have bandwidth. This link is only 10 Mbps link, because when you purchase a link from a vendor, they will tell you what is the speed. You just need to purchase 10 Mbps, 100 Mbps, 200 Mbps. Based on that, you get the subscription. So this is 10 Mbps, or you will just upgrade it to 10 Mbps. Then this user will get 100 Mbps speed. So based on that, you will also need to set the speed of the interface. Okay, so that is called speed, and that is called duplex. You always, as an administrator, you need to check speed and duplex of the interfaces when any user are saying, I am getting problem. Okay, so how you will get this problem, because how you will come to know there is a problem, or you will miss like configuration, because when you check the interface, you will see all the output. So like if you see, then what happened, like if this kind of condition is happening, like duplex mismatch and happening, then you have on the interface, to find out the reason, you have counters. You have runs, GNDs, input error, CRC, frames, duplex, or so this counter you will check, okay, I'm getting increase in a counter. So I'm getting CRC error. Mostly duplex mismatch means CRC error. The packet is transmitted, but it will be distorted between the transmission. So CRC will be failed. CRC, like cyclic redundancy check, will be failed. We will learn this when we will go to Ethernet packet. Then it will be, the counter will be increased. So maybe if 10 packet is transmitted, okay, and 10 packet is not delivered to the destination, your CRC value increased to 10. You will see and log in, okay, where is my CRC? So if you see here in the left corner, you see here, you can see there is one value called CRC. See here, GRC is 0, right? So you see here it will be increased to 10. Then you can say, then you will see, okay, my CRC is green. Then definitely it may be the duplex mismatch, where I need to check the configuration of the interface of both the sides. So both the sides are switch, you will log in and check the interface configuration. Then you will found, okay, then, and if it is the same, then you need to you need to go for another conditions. First, you will check, okay, this is CRC, I need to check. So that's why we have counters. Every device interface have the counters. We just log in and check the counters. And based on the counters, the engineer came to know this may be the problem. Okay, that's why this slide I left, because without knowing this two thing, you will not know the counters. So this two configuration can impact to your counters. Okay, so that's all for today. It's almost 2 hours now. Yeah.
Yeah. Can I see that? Can I see that screen again for the errors a while ago?
Yeah, sure. See, this other are also here. I will tell you other counters when we go for Ethernet packet to be learned, because this is not only one condition. There are more than 10 conditions for condition for the communications is not happening. So just like CRC we just talked about, this is mostly related to physical issue. So duplex, speed, cable is faulty, cable is not connected. It is loose connection is there. Port went faulty, port is not getting power. Sometimes the port is not, there's a LED in between the port. The LED is not blinking. Then you will come to know what happened, that port is faulty. Then what you will do, you will take another cable, connect a new cable, which is working one, then check, okay, LED is not coming. Then you will come to know my port is faulty. Kind of condition is it. So in that condition, what happened? The CRC error will be increased. Okay, so then you will know. Other counters are also here. I'll tell you about these counters, because this counter is related to packet size, and packet size we will learn when we learn about the Ethernet packet.
All right. So the main things I have to learn about the wiring is the copper and the fiber optics.
Right. Yeah.
And then when we come to the duplex stuff, the duplex is about the duplex is just the wiring and the issues that could happen between a PC and a switch, or a switch to a switch.
Yeah.
So it doesn't matter.
Go ahead.
Duplex, that issue, it could happen whether it's fiber optics or it could be with copper, right?
Anything.
Okay,
Anything.
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 Any type of
Basically,
connection.
Any type of connection. Basically, the
Okay.
duplex speed is limit is actually resides on your interface configuration. So as an engineer, you need to decide, right? You are admin. So you need to decide what condition of my cable. So you now these days, there is no condition like half duplex. You always get the cable which have capability of having the full duplex. So you will always set to auto or full. But the condition
Right.
it should be same to the another side. Okay, that is the requirement. Both the sides should be auto, both the sides should be half, or both the sides should be full, but it's your responsibility to make it okay. That's what the
Let me
duplex.
ask you, well,
Mhm. Go ahead.
for the exam, you know how you have that? Oh no, go back to the last picture.
Mhm.
No, the one of the fiber optic.
Okay, yeah. Mm.
Yeah. You see how it has the core, then what's it
Mm.
called? The cladding,
Cladding.
the are they gonna show you these pictures or something and you need to know what each area is for the exam?
No, that is not you need to focus on. We just need to know what is the fiber cable and
Right.
yeah, there is no question such like why this is buffer, strengthener, or the outer
Okay,
jacket. So
okay.
this is no need. Just need to
You
know
just
what is they will to have one question like what is multi-mode fiber, what is single mode fiber.
okay.
They will ask you like that in case if you go for interview, they will ask you, okay, what is multi-mode fiber? Then you need to take, okay, the multi-mode fiber is having lesser distance to cover. Why? Because it can transmit multiple angles. The light can be transmitted in a multiple angles to the core of the optical fiber. That's why it is called multimode and it is having very less distance. It can only having 10 gigabit of speed over fiber over 400 meters. So only 10G can be configured on a 400-meter basis. Not more than 10G can be given because of their implementation. So then they will ask, okay, what is single mode? So then you need to tell only single angle mode can be transmitted, light can be transmitted to the core area of the optical fiber. So that's how they will ask you.
does it does it
Mhm.
tell you how much gigabytes single mode could go?
Yeah, yeah, sure. So what happened? I will tell you. See, this is just like this is only the configure. So we have different categories. 10 base LX LH SFP. So 10, this is speed. Okay,
Hmm.
support 10 kilometer on single mode fiber. So if you are using this particular fiber, then you can go for 10 kilometer with 1000. This is speed, okay? This is 1000 means 1 GB. This is actually
Hmm.
Mbps. Okay, so this is 1000 Mbps means 1 GB, right? So this is
Hmm.
1G, 10 kilometer. Then you have 40 kilometer as well. So this is 1 Mbps. Sorry, this is actually, yeah. Oh, sorry, 1 Gbps. This is actually 1000 MB, 1 Gbps with till 40 kilometer. So this is one more type of single fiber you can use. Then you have
Okay.
10 GB as well. So different. So what happened? The fiber is not so is a condition. I'll tell you. Uh, See, this is port, right? So this looks like to port which is connected for RJ45. The fiber cable is not directly connected to the switch. It need one more device that is called SFP, small SFP. So
Okay.
SFP module. So you see here, this is SFP module. So SFP modules, see, this is finisher. Yeah. So one will be transmit, one will be receive. I told you, right? Full duplex. So full duplex mean one will be received, one will be transmitted. So this means
Right.
this will become TX, one will become RX. This is a SFP. So your fiber cable, see, this is with this. See, this is the two white things you are seeing here, right? That is your fiber
Hmm.
cable. It is connected to your SFP. SFP is connected to the switch. It is inserted to the switch
Okay.
port.
I got it. Got it.
Yeah. Yeah, so that is one is TX, one is RX, then it's going to the SFP, SFP is going to a switch. Then see in the left side, you can see there is RJ45 connection as well. So this switch can have SFP as well as RJ45. So mostly RJ45 will be given to your local area network, LAN connection, maybe PC, your printer, your IP camera, and other thing. And this will be given to uplink, maybe another switch or router. You got it?
Yeah.
For your access endpoint devices. This is for your core network or distribution layer. So this will be like that. So this is how you can connect. So based on that, what happened, the speed and other things. So once you will go to the data center, and when you become the administrator, the user will come and ask you, okay, what is my, so you will tell you my requirement is 10 GB. So user, based on the user, you will get the requirement. Okay, we need 10 GB of transfer. 10 GB of speed we can have. So you need to tell, okay, for that we need to purchase the SFP which can support 10 GB LR, 10 kilometer of connection. So, okay, between two devices, if you have 40 kilometer, then you need to purchase 10 GB ER. 10 GBs ER SFP, and then lay out the single mode fiber till 40 kilometer. Then again, if you're 80 kilometer, so based on the distance and application, you will always give the answers to the people. I need this device, this equipment to be there on my data center so that I can manage. Okay, that is called the architecture. So you will, as an engineer, you will tell people, I need this SFP for this kilometer. So you will just search and tell them.